Hi, my name is Thayer Morrill. I'm a game theory professor at NC State University. This video is going to cover how to solve Bertrand's model of oligopoly. Oligopoly is just a fancy way of saying a couple of firms. This is one of the most important games. It's covered in every single game theory class. All right, so let's start by understanding what the game itself is. Okay, this is our game. We have two firms, and each firm is going to simultaneously choose the price for their product. Customers are going to buy from whichever firm sets the lowest price. How much are they going to buy? Well, to keep things simple, we're just going to have a nice, easy linear demand, which is to say that the quantity they sell is going to be some parameter A minus the price they set. Each firm has really simple costs, which is to say that they have a constant marginal cost of producing an object, equal to some parameter C. This is basically the identical setup to Cournot. The only difference with Cournot is that in Cournot, the firms pick the quantity they're going to sell, and that determines the price. Here, they're picking the price, and that determines the quantity they're going to sell. And the fact that it's so similar to Cournot is actually what makes these the classic games. It looks so similar. It looks basically identical. It looks like we should have the same prediction, but we're going to find we have a very different prediction in Bertrand than in Cournot. Okay, so first of all, sometimes students seem to hate these parameters, these letters A and C. But these are just numbers. So if you don't like the A and C, just put a number in there. There we go. Let's go 120. It doesn't really matter. That's not the important part of the question. All right. So how are we going to solve this? We always have two approaches to solving a game, which is we can either solve by best response or incentive deviate. Incentive deviate is like guess and verify. I always like to start with best responses. It's constructive. We don't have to be very creative. So let's start with there. Let's try to figure out what a best response is to a strategy. Let's say one of the firms chooses 40. What would be my best response to 40? There's actually no mathematics here. This is just understanding the game. Your competitor has set a price of 40. It only costs you 20 to make the object. What price do you want to set? Well, you want to set your price just a little bit below his. You want it to be as high as possible so you make the most money, but you want it to be below him. That way you're the one who sells to all the customers. Okay, so I can think of a lot of really good responses to 40, like 39.9. 39.9 is a really good response to 40, but is it the best response? And unfortunately, no. So 39.9 is good, but 39.99 is even better. But 39.999 is even better than that. And so there's no best response here. You don't have to do calculus to figure this out. You just have to understand the game. That I want to get as close to 40 as I possibly can, but there's no one number that is as close to it as possible. So we can't do this by best response. We have to do it by incentive to deviate. That just means we got to take some guesses and try to figure out a pattern. All right, so you can guess whatever you want. I'm going to start with actually a really silly guess. Now remember, our costs are 20. So it'd be really stupid for a firm to set the price below their costs. But, we want to see if there's some stupid equilibria. So how about if firm 1 sets a price of 10 and firm 2 sets a price of 15? Now we should expect somebody has an incentive to deviate. And of course they do. Firm 1 is losing a lot of money here. It costs them 20 to produce. They're only selling it for 10. They're losing $10 in everything they sell. So better than making negative profits, they can offer anything that's 20 or higher, and they'll at least make 0 profits in that situation. So firm 1 has an incentive to deviate here. So this is not an equilibrium. All right, so how about both choose 40? And again, this isn't really about doing any mathematics. This is just understanding the logic of the game. If your competitor has set a price of 40 and you're setting a price of 40, you're doing fine. You're selling to half the market at a price of 40. But can you do better? And the answer is sure. You just want to offer a slightly lower price. So like 39 would give me higher profits than offering 40 here. I get almost the same price, but now I'm selling to the whole market instead of half the market. So this is not an equilibrium because either firm has an incentive to deviate. All right, so we're just looking for all the different scenarios. What if one firm, let's say firm 1 is doing 36 and the other firm is doing 40? Does either firm have an incentive to deviate? Now this is a fun one just to, again, to check your intuition behind best responses. It should be clear that firm 2 wants to change their price here. They're selling nothing. They set their price too high. And if they set a price of 35, they'd sell to the whole market. So firm 2 definitely has an incentive to deviate. And that's all you need for this. But just to check yourself, ask yourself, does firm 1 have an incentive to deviate? And the answer is actually yes. So they're doing really well here. They're selling to the whole market at 36. But they could do even better, which is to say that if they raise their price to 38 or 39, they'd be making even more money. They still sell to the whole market, but at a higher price. But all that matters is at least one of the firms has an incentive to deviate. And so this is also not a Nash equilibrium. So we don't have too many scenarios left. We know that nobody sets a price below their costs. We know that they don't set the same price above their costs. We know that they don't set different prices above their costs. None of these would be equilibria. So now we just have to figure out what cases remain. Okay, here's one we haven't covered yet. One firm sets a price at their costs. The other firm sets a price that's higher than their costs. So let's say 40-20. So does firm one have an incentive to deviate? They're getting profits of zero. They set their prices too high. Maybe a little surprisingly, but firm one does not have an incentive to deviate. Right now, they're making zero profits, but if they set a price below 20, they're going to get negative profits. There's nothing they can do to make any profits. But firm two does have an incentive to deviate. Right now, they're making zero profits. And if they raise their price to 30, 35, 38, they would be making positive profits. And again, we don't have to figure out the best response to this. We just have to figure out any alternative that gives them higher profits. So we've covered all the cases except the last one, which is what if they both set a price of 20? This is not very good for the firms. They're both making no profits. But is there anything they could do, anything change they could make to make positive profits? Well, no. If they raise their price, they don't sell to anybody. And if they lower their price, they're losing money because 20 is their cost. So neither firm has an incentive to deviate. So this is our Nash equilibrium. Both firms set a price equal to their marginal costs. And this is really interesting. Cournot, we found both firms make close to the monopoly profits. Here, this is both firms are making zero profits. And it's really, really fascinating to think about what was so different about these two games, because there really is not a lot of difference. In the one, they're choosing quantity, the other choosing price. So I highly encourage you to get a cup of coffee and try to think about why these outcomes are different. But for now, just make sure you understand how this game is solved. And the Nash equilibrium here is both firms set a price equal to their marginal costs, and both firms make zero profits.